Hi everybody. I'm just going to go through just two examples about finding some relatively local extrema, and the directions here are going to be that for each function that we're given, I'm going to ask you to determine any relative extrema and where the function is increasing and decreasing. So remember, finding these extrema, it's all about checking endpoints, which I'm not giving you this time, so you won't have to do that. But looking at where the derivative is 0 to see if you have a nice smooth min or max, or where the derivative is undefined because you might have a pointy min or max, right? That's kind of the gist of it. Go back to that first video if you're stuck and just review that first part. Okay, so it's all about using the derivative to determine where extrema might exist. So we're going to find the derivative. I'm going to get a 12x to the third minus 12x squared, and we're going to find out where that derivative, I'm going to just simplify this a little bit, or factor that, so we're going to find out where that derivative equals 0, and we're also going to find out where that derivative is undefined. And I know that's a cubic polynomial. It's never going to be undefined anywhere. So we're going to just rule that out, but notice I keep checking, okay? And then we find some candidates for our extrema. We know that the derivative is going to be 0, which means it's a potential to be a nice smooth min or a max at x equals 0 and x equals 1. And the way to check to see, does the slope of f, this original function, really change from positive to negative at either of these points, or negative to positive, because that's what would make a min or a max, then you have to check the first derivative. That's what's going to tell you if your slope changes. So I'm going to go ahead and put in a 0 and a 1, and I'm going to go up here because I like this to plug in values much better because I don't have to do work. If I plug in something really negative, negative squared is positive, times 12 is positive, and a negative minus 1 is negative. So a positive times a negative, my derivative is negative here. So the slope of f is negative there. F is decreasing there. If we go here and we plug in something like a half, 12 times a half squared is positive. The half minus 1 is negative, so when I multiply them, it looks like my function f, this one right here, is still decreasing. It still has negative slopes. And then when I go over here to plug in something positive, I'll go with a million. This is a really big positive number. This is a million minus 1, still a pretty big positive number. And so our derivative value will be positive there, which means our slope of this graph is positive there. So when we're looking at this, we can easily determine where the actual function f is increasing, and I'm going to abbreviate that, and we can find out where f is decreasing, going downhill, just by looking at the slopes. F is decreasing from negative infinity to 1. It has negative slopes. Then f is increasing on 1 to infinity because its derivative, its slopes are positive. And right here at 1, we got something going on at 1. We can see that f prime changes from negative to positive at 1. So what is that going to be, a min or a max? And the justification is because f prime changes from negative to positive there. And you should say there, right? Exactly at 1. And what would that make? If you said a min, you're absolutely right. The function goes downhill, negative slopes, uphill. So that would make it a min. All right, and you should probably, I'll show you the next example, and you should probably pause me. Come up with all your candidates and what you think is going to happen. All right, once again, no endpoints. So I'm going to use the derivative. It's the only way I'm going to get my candidates. And we're going to find out where that equals 0 and where that is undefined, and it's never undefined. So once again, that problem is not going to be undefined, so we're pretty sure that we're not going to have any candidates from that. We're very sure. And then if we add 4, divide by 3, and take the square root, I'm getting 2 over root 3, and it would be a plus or minus because we chose to take the square root there. So those look like my only candidates. I have no endpoints. Derivative is never 0, so these are the only two candidates, and I might have really smooth, right? The rounded type of mins or maxes where the slope is 0. All right, so I'm just going to put my negative 2 over root 3 here, and my 2 over root 3 here, and we're going to just kind of plug in some values. I know that right in between here is 0, so if I plug a 0 in here, I get 0 minus 4. That's negative, so the slope of our function f, its derivative is negative here, so our function is going downhill there, it's decreasing. All right, let's go ahead and try something here and here. I'm going to plug in negative quazillion. I don't even think that's a number, right? But I'm going to plug in a huge number and square it. Huge negative number squared is huge positive times 3 is huge or positive. Minus 4 means really nothing. We're going to be positive here. And if I plug in a super positive number and square it, it's super positive times 3 is more positive. Minus 4 doesn't amount to a hill of beans. It's still going to be positive. And we can really quickly come up with where the actual function of f is increasing. Go ahead and see if you can write it in interval notation. Where is f decreasing? And we have, where do we have mins or maxes? I'm going to put a min at and a max at. And you need to justify how you know by explaining your sign chart. And if there is not a min or there is not a max, you just write doesn't exist. There is none. Okay, so turn off there and see if you can figure it out and then come on back. Okay, I'm getting that f is increasing, has positive slopes on negative infinity, negative 2 over root 3. And then again at 2 over root 3, infinity. And it's decreasing in between those. Alrighty, I think we're going to have a min at x equals and that is because f prime changes from negative. There. So right here, f slope changes from negative to positive. That means that's a min. And we'll have a max at x equals negative 2 over root 3 because okay. Now, I'm going to go and ask you another question at the top. Kind of neglected to do it because I want to get the sign chart sinking in. A minimum, and we didn't really say, change at x equals 1, right? That's where we have a minimum at x equals 1. But if you remember from the last video, we said, hey, you know, when they ask you for a the minimum value, they really want the y. So let's go ahead and write down what our minimum would be. If it occurs at x equals 1, what value would you get for your minimum? Okay, and when we plug in a 1, we're getting negative 1. So our minimum value would be negative 1. And now you're going to be really upset with me, but let's go ahead, pause yourself, and see if you can go ahead and find the minimum value. You're going to have to plug in a 2 over root 3, right? It's not as hard as you think. And a maximum value. Okay, go ahead and do some little bit of algebra and let me see if you got it right. For my minimum, I got negative 16 over 3 root 3. I don't really care if you rationalize that. And for the maximum, that's 16 over 3 root 3. Okay, so keep in mind that when sometimes they ask you the x values of the min or max, in which case this would be fine. Sometimes they ask you for the minimum value or the maximum value, and that's when you have to do a little extra work of plugging things back in. Alrighty, folks, that's all I've got for you right now.